I think you all might be seeing this diagram. Diagram दिख रहा है आपको?
Yes, sir.
So what is this diagram? It is the load frequency control and voltage control of synchronous generator. Load frequency control and voltage control loop. There are two loops. One is the load frequency loop called the automatic load frequency control, and there is the voltage control. This is the load frequency control loop here, and this is the voltage control loop. And this automatic load frequency control loop, again there are two. It is a primary automatic load frequency control loop. This is a secondary automatic load frequency control loop. And this primary automatic load frequency control, where this senses the speed, it gives the signal with the help of a speed governor, amplifies it, then changes the fuel. This is the primary automatic load frequency control. We describe this in very much detail, the functioning of this diagram. Then we have developed, then the detailed schematic diagram of this was described, and this was described through this diagram. The detailed description, detailed schematic of that primary automatic load frequency control loop was here, where again we have shown in the last class. It is a speed governor. Speed is sensed here, and this speed is converted into this motion here, distance, and this displacement is converted into this displacement, and finally this displacement changes the more high pressure oil to flow into the main piston, which causes the fuel to flow into this, and this fuel is controlled. This fuel is controlled so as the input is equal to output. And then we described the model of, we have written the equation for each limbs here. You have written the equation here. We have written the equation here. Then we have written the equation for here. And those equations, after writing those equations, and we have seen one of them equation was having the integration sign. So we have taken the Laplace of all these three equations. These were the three equations, and these equations, then putting the value of one into another means intermediate terms. After eliminating the intermediate terms, we get this equation YE, means how much fuel opening will be there because of the either change in frequency or change in input power setting. If we change the input power setting, means 100 megawatt ki jagah, suppose we want 110 megawatt because the demand has increased. So this can be changed from the input setting. And if there is a change in frequency or if there is change in the speed of the speed governor, then it understands that power demand is more or power demand is different than the power supplied. So this accordingly, this again allowed to change this del by E opening of the fuel. So this was the final equation. We tried in detail, and finally we have written this equation in this form. Equation was written in this form: del PC minus 1 by R del F, where R is the speed regulation of the governor. This means speed. Speed, in according to the speed, this is converted into the signal displacement of the fuel, and this is the power del PC input power setting, and this KSG was the gain of the speed governor, means it converts the power into the displacement signal. This is the time constant. So this is the KSG was this gain of the speed governor, TSG is the time constant, which was equal to this. And this equation was again represented in the form of a block diagram model. This was the block diagram model. So up to now, yesterday we described this KSG 1 plus SG speed governor block diagram, or you can say transfer function of KSG by 1 plus TSG. It is a transfer function. This is same. This is taken from here, KSG 1 plus STSG. It is a and del PC is this, the del F by R from here. Del F by R means if the change in frequency or change in speed according to this regulation, it's converted into the power signal. This is the power signal, and because of the both things may happen simultaneously, input setting input power setting and the change in speed can happen simultaneously. And net balance, according to the net balance, the speed governor causes to open the fuel opening. So this was the complete block diagram representation of the speed governor system. Up to now, is there any problem to anyone of you? If you have the query, we can discuss here, then we can move ahead. So is there any problem up to now? इसमें किसी को कोई प्रॉब्लम है?
No, sir.
Deepika? Yes. Now
No,
you
sir.
see this one. Yes, this was the speed governor. Only here again we come on this figure, this diagram. This was this complete block diagram. It was the control system block diagram of this system. Now we describe the block diagram of this turbine. Although this turbine here shown is a one prime mover, that it takes the fuel, and this fuel here, from here it takes the fuel, maybe in the form of steam or otherwise. This fuel then causes to rotate the rotor inside this, and this turbine model, it is a prime mover, this is a engine, but in fact in the power system here it is only it is a one unit. It is shown in the form of one unit, but in fact in the power system, if you visit the power generating station, the turbine is not only a single prime mover. ये एक इंजन की तरह नहीं है. If in case of a small synchronous generator, जैसा आपका घरों में synchronous और घरों के अंदर आप अल्टरनेटर और जनरेटर लगाते हैं, there it can be simple one engine like this turbine, but in fact in the power station, at generating station, it is not a one unit, there are a number of units. Here there can be a high pressure turbine. First of that means this can be number of units. One unit is a high pressure turbine, it converts the fuel into high pressure, then high pressure, then next unit is the intermediate pressure turbine, means the fuel which is entering into this in place of a high pressure. After utilizing this at one unit, this fuel again goes to the intermediate pressure turbine. Then here again that pressure is converted into the torque. Then again that pressure of the oil goes to the next unit of the turbine called the low pressure turbine. Then it can be another low pressure turbine. Then finally this torque is net torque is going to the rotor side of the generator. So in fact actually this turbine is a number of units, but here just to understand the things, we have considered only a one unit turbine. And this turbine, the role of this turbine is to take the fuel into this, convert into the mechanical energy here. This chemical energy is converted into the mechanical energy, and rate of change of energy is called the power. ये किस रेट में आपको एनर्जी को कन्वर्ट करके इसमें पावर में लाता है, मींस दिस पावर इज कन्वर्टेड इनटू द मैकेनिकल पावर, एंड द कन्वर्जन टाइम is called the time constant, T tau. T tau is the time constant of the turbine, means it takes this much time, T tau time, to convert this energy into the mechanical energy. It can be in the form of potential energy if it is a hydro, it can be in the form of chemical energy if it is a thermal or nuclear or any other. So time requirement depending upon nature. If it is a hydro turbine, time constant is less. If it is a thermal, then time constant is slightly more. If it is a nuclear, time constant is very high. So it means it takes the more time to convert this energy into this energy. Similarly, so depending upon what type of turbine, there is a time constant. Another thing is the gain. Gain means if you input this, how much power, means kitna energy aapka out of 100 unit, how much it will be converted. So this is a means this signal, if some signal is given to this, YE signal is given to this, and according to the signal, how much power is converted. So any system, it can be represented in the form of a block diagram model. So the turbine model, for simplicity, turbine model is considered like this. KT1 by, it is a single order, turbine model is a single order, although as I told, there are a number of units and there can be multiple. This model can have the transfer function with high order transfer function, but for simplicity it is considered as a single order transfer function, where so del ye means it takes the input ye, how much opening is there, opening for the fuel is there, and depending upon the opening how much power it is giving, it is a pt. For this ye is giving the pt, for ye1 it given pt1, by ye2 is giving pt2. चेंज इन ओपनिंग, जितना आपका ओपनिंग ज्यादा होगा उतना ही पावर ज्यादा देगा, मींस जितना ओपनिंग ज्यादा होगा उतना फ्यूल ज्यादा होगा, जितना फ्यूल ज्यादा होगा उतना पावर ज्यादा देगा. एंड इट इज अगेन टू रिलेट दिस, वाई अगर 0.1 है तो ये सपोज 10% है, 0.2 है तो 20% है. सो इट इज अगेन constant, proportionate constant. And how much time it will take in conversion, it is a time constant t tau. So it is a time, it is a block diagram model of turbine system, and you can call it as a turbine transfer function model. Tt is the gain, Tt is the time constant. So this is a turbine. So it means here this, what is this ye? Ye, if you see here, this is a ye, means जो हमारा इनपुट पावर सेटिंग, अकॉर्डिंग टू इनपुट पावर सेटिंग एंड हाउ मच चेंज इन फ्रीक्वेंसी, how much change in the speed of the turbine with the net, this is also converted to the power signal. And according to the both, means the net requirement, आपने इनपुट सेटिंग 100 से 110 कर दिया और फ्रीक्वेंसी सेइंग कि हमारा फर्दर उसकी स्पीड डाउन जा रही है, so this will again say 10 more megawatt, because of the low speed we want 10 more megawatt, and it is saying the requirement has increased from 100 to 120. So 20 plus 10, according to the 20 plus 10, 30 megawatt, according to 30 megawatt, this signal will go. And accordingly, there will be opening. And if it is the opening of the fuel valve, then the turbine, this fuel valve means this opening means more fuel will go to the turbine, and this turbine will convert here the power, mechanical power output. So this here you can say the turbine is connected here. This turbine model is like this. It will take ye as the input, pt is the power output of the turbine. Okay, so I think it is clear now. Now there is a, again we come here, turbine. It is a primary automatic load frequency control that we described here. Then the turbine model we have described. Then we will describe this generator. So it means then we have completely understood this portion. This is a generator. So now we will describe how the modeling of the generator is done. Then the complete block diagram for at least primary automatic load. It is a primary automatic. Later on we will consider the secondary automatic load frequency control. But first of all, the working of this or the control circuitry, control of the primary automatic load frequency control system will be described. So this is the, we have developed this, we have developed the model for this, now we develop the model for this, and from here we know how much power is going out. This is simply a transformer. It is just time constant is very like a negligible. So directly whatever power is coming from here, that power is available to here, to the load. Thus, now let us have how to develop the model of the generator. This is this generator model. Now generator stores kinetic energy in the rotor. When it takes the mechanical power, it restores kinetic energy into the rotor. Kinetic energy is stored per unit rating. PR is the rating of the generator. If the machine is small, it can be 10 megawatt, it can be 100 megawatt, it can be in the generating station, it is high, always higher side. Higher means 100 megawatt, 200 megawatt. So देखिए जितना मशीन बड़ा होगा उतना ही और यू कैन से जितना जितना रेटिंग ज्यादा होगा उतना ही मशीन का साइज ज्यादा होगा। रेटिंग मीन्स अगर 100 मेगावाट मशीन है तो साइज बड़ा होगा, 10 मेगावाट मशीन है तो साइज छोटा होगा। तो फॉर द 100 megawatt machine the size is very big, sometime bigger than the size of your labs in the you might have seen in the classes, in the laboratory classes. So the size of the generator is very very big. Sometimes it is more than the size of the 4-5 rooms of the houses. So if the size is rating is high, the size is high. Size is high means kinetic energy stored, it will be more. If the size of the generator or size of the rotor is high, then half I omega square is the energy stored. Kinetic energy stored into the rotor is half I omega square. So it will be, if the size is more, means I inertia is more, speed is according to 50 Hertz, 1500 RPM, then half I omega square the kinetic energy stored. So kinetic energy stored is proportional to the rating. If the rating is high, kinetic energy stored will be high. Then this is a proportionality constant which we can call as a kinetic energy stored per unit rating. Means it is a constant one. कि अगर हमारा रेटिंग ज्यादा होगा तो एनर्जी ज्यादा स्टोर होता जाएगा। तो it is called the inertia constant, which is called as inertia constant, and it is defined as the kinetic energy stored per unit rating. Why it is required to define inertia constant? क्योंकि देखिए, when we will study the generator, the kinetic energy will be stored for each generator, but since we know the rating is standard terms, we know what is the rating of the machine, multiply it with this inertia constant, because this is constant, so this both will give you how much energy has been stored into the rotor. कोई भी जनरेटर है, छोटा है बड़ा है, तो आप उसका पता कर देंगे कितना एनर्जी उसके अंदर स्टार्टिंग में स्टोर हो गई है। दैट इज द stored, that energy is responsible for the stability of the system, कि क्योंकि वहीं से जो एनर्जी आपकी रोटर में इनर्शिया में स्टोर हो जाती है, उसी एनर्जी से जब हम एडिशनल पावर इंक्रीज और डिक्रीज करते हैं तो टेम्परेरीली पावर कम्स फ्रॉम दैट। जैसे कि आप सपोज करिए, आप यू डू सम वर्क इन द सम फिजिकल वर्क एंड यू टेक सम इनपुट energy in terms of your meals. So whatever input you are taking in terms of meal, accordingly you do the physical work. But sometimes you don't take the meal, but you do the physical work. Then this power comes from the stored energy from your body. So it is like that, stored energy of the generator. Okay, so this is like that. So this is responsible for stability. Suppose you have not, if you are ill, sick enough, and you don't store energy in your body, then, and you are not taking the meal, then suddenly if some extra load will come, you will be collapsed. Similarly, here extra load will come if energy has not been stored, sufficient energy not has been stored, then the generator will collapse. Okay, this is the reason that it is responsible inertia constant is responsible because of this high inertia system is a stable one. But anyway, here our purpose is to obtain the model of the synchronous generator. So we know WKE0 means normal. At normal speed means when the frequency is 50 Hz. Normal, when it is running normally, when 50 Hz frequency is there, at that time energy is stored again by H into PR. Okay, and this energy is stored, any energy stored into the rotor is given by half I omega square. Energy होगी क्या? What is the formula for this? It is half I omega square. I omega means I is constant, inertia constant, and omega is the frequency, proportional to the frequency. Angular speed is there, so it is proportional to the frequency, means it is proportional to the kinetic energy is stored, is proportional to the frequency square. I half I omega square. It is proportional to frequency square, means F0 is, if it is a kinetic 50 Hz, so F0 square. Here it is proportional to F0 square. So if kinetic energy is different, because you are going to study the different changes, so kinetic energy at different instant of time may be different. जब आपका लोड बढ़ा तो kinetic energy stored may be changed. At certain instant when kinetic energy WKE 0 means at normal running condition. When it is not normal, kinetic energy WKE, and it will be proportional to the frequency square F square. F can be some deviation from the normal frequency. So means F0 plus del F. F0 is the power frequency. If the energy is high, then frequency will be F0 plus something del F. And if you divide the two equation, mean Wk0 H into PR, or this is proportional to the F0 square, Wk is equal to F0 plus del F square. If you divide the two, this equation will come. Okay, and in place of kinetic energy stored, you know it is in terms of H into PR. This is constant. This is a rating of the machine. Okay. Is there any question up to this now? While developing the model of the synchronous generator, this equation comes. Anybody is having any question up to this point? Santram? Deepika?
No, sir.
So I hope you might have understood all of this equation. Now, since the kinetic energy stored is the energy and we are concerned with the power, means change in energy is the power, because the demand is increased. In place of demand is increased means earlier demand was 100 megawatt, suddenly it become 110 megawatt. It means demand has come from 100 to 100 megawatt. This demand will be served from the kinetic energy stored. So how much amount of energy is taken per unit time from the stored energy is the power. So if you differentiate kinetic energy per unit rating, means WKE per unit time, then it is the power taken. This power will go to the to meet the demand. So this differentiating this energy with respect to the time, this is called the power taken from that. So if you differentiate this HPR, differentiation of 1 will be 0, differentiation of del F will be del F by dt, like this. This equation will come. इसका differentiation करेंगे तो ये आएगा. This is the power taken from the generator. This power taken from the generator, here you see what is our problem. Our problem is del Pg minus del Pd, means generation is 100 megawatt and demand is say 110 megawatt. So this is del Pg by del Pd. This will be supplied. This should be supplied from here. This should be supplied from this. In addition to that, now देखिए, सपोज करिए इसके अलावा आप सपोज करिए 100 मेगावाट आपका डिमांड था, एंड बिकॉज ऑफ द and generation was also 100 megawatt. Now from 100 megawatt demand has become 110 megawatt. तो क्या होता है, if the demand is high before the control, I am talking before the control, if the demand is high, so you have seen or we described in the very two lecture, it takes the energy from the rotor, so rotor speed goes down. When the rotor speed goes down, the frequency goes down. And what is this demand? हमारा demand, when we say demand is 100 megawatt, what is the meaning of demand? Demand किस फॉर्म में होता है? Demand, electrical power demand on the grid. What is the form of this? इससे जो demand होता है उससे हम क्या load चला रहे होते हैं? What type of load is connected on the grid? Grid पे हमारा जो load connected है वो किस type का load है? Mostly there is a industrial load and commercial load, and very less it is a domestic load. So if it is a commercial load or if it is a industrial load, what type of load is there in the industries? Industries के अंदर किस type का load होता है? Electrical load. Mostly they are induction generator. Mostly they are induction motor. Induction machine होता है. और उसमें क्या है? उसमें क्या जो हमारा मोटर्स होते हैं और एनी अदर मोटर आल्सो, अगर वो मोटर्स रन कर रहे हैं तो इसका मतलब क्या हुआ? मोटर डिमांड इज इन टॉर्क इनटू मेगा. जैसे सपोज करिए आटा चक्की है, आपकी पावर सप्लाई से आटा चक्की चल रहा है, फ्लोर में चल रहा है, तो उस पे जो सिंक्रोनस इंडक्शन मोटर लगा हुआ है उसके ऊपर आपका लीड्स फ्लोर मिल में आपका गेहूं जा रहा है, टॉर्क इनटू मेगा. तो टॉर्क मींस जितना आपका वेट आपने लगाया हुआ है, ओमेगा उसका स्पीड है. तो अब क्या है, देखिए आपने देखा था जैसी डिमांड बढ़ा था तो फ्रीक्वेंसी कम हुई थी, और फ्रीक्वेंसी कम हुई थी तो जो हमारा लोड था, लोड वाज द टॉर्क इन 2 मेगा। ओके, सो इट मींस अगर स्पीड कम हुई या फ्रीक्वेंसी कम हुई तो डिमांड भी कम हो गया। कहने का मतलब ये है, मैं आपको थ्योरेटिकली भी एक्सप्लेन करूंगा, केवल फिलहाल ये कह रहा हूं कि अगर आपका 100, सपोज करिए 100 मेगावाट डिमांड इमीडिएटली बढ़ गया, पहले आपका सपोज करिए 100 मेगावाट था और 100 से 200 मेगावाट हो गया डिमांड। 100 मेगावाट एडिशनल डिमांड होने की वजह से एक तो ये पावर वहां से ड्रॉ करेगा, पावर जनरेटर से ड्रॉ करेगा, एज आई टोल्ड कितनी पावर ड्रॉ करेगा ये। उसके अलावा इसकी इसकी फ्रीक्वेंसी भी कम हो चुकी होगी, बिकॉज ऑफ द इसने रोटर से पावर ड्रॉ कर लिया है, स्पीड कम हो गई है, तो इसकी फ्रीक्वेंसी भी कम होने से डिमांड की वैल्यू भी कम हो जाएगी। मींस अब आपका डिमांड 100 मेगावाट नहीं रहेगा। थ्योरेटिकली वी विल डिस्क्राइब यू लेटर, बट प्रैक्टिकली यू अंडरस्टैंड। अभी जस्ट आप ये आप समझें, अगर 100 मेगावाट इमीडिएटली डिमांड बढ़ा तो 97 मेगावाट इट विल ड्रॉ फ्रॉम द रोटर एंड 3 मेगावाट डिमांड विल बी रिड्यूस्ड बाय इटसेल्फ, क्योंकि आपकी फ्रीक्वेंसी कम हो गई है तो डिमांड भी अपने आप में कम हो जाएगा। सो इसका मतलब क्या हुआ, 97 यहां से आ गया, 3 अपने आप में कम हो गया डिमांड, और फ्रीक्वेंसी भी आपकी थोड़ी कम हो गई, और लो फ्रीक्वेंसी में हमारा सिस्टम 100 मेगावाट है, तो सपोज 50 की जगह आपका 47 48 पे हमेशा रन करना शुरू कर दिया, उस पर रन करता रहेगा। ये इस टाइप की स्थिति इसमें बनती है। बट एनीवे, वी आर नॉट हियर, वी आर डेवलपिंग द मॉडल। सो how much energy means this we have described. This much amount of energy will be supplied from the rotor, and demand itself will be reduced by del PT V into del F. Demand भी इतना कम हो जाएगा, V is the sum point, frequency कम हुई है, as I told it is proportional to the frequency, demand is proportional to the frequency, so demand कम होने से frequency कम होने से आपकी demand भी कम हो गई। इसका मतलब क्या हुआ, अब देखिए राइटिंग द इक्वेशन PG माइनस PD, जनरेशन और डिमांड में जो डिफरेंस था, एक तो ये रोटर से आ गया, दूसरा डिमांड अपने आप में कम हो गया, इस तरह दिस इज बैलेंस्ड। नेट डिफरेंस इज बैलेंस्ड बाय चेंज इन द रोटर एनर्जी एंड चेंज इन डिमांड इटसेल्फ। दिस इज द इक्वेशन which describe the working of the synchronous generator। ये हमारा आ गया। now this equation again converting it into the per unit system, divide it by rating। यहाँ देखिए, here it is a PR, if you divide it by rating means PG minus rating। आपको 100 मेगावाट का अगर सिस्टम है तो डिवाइड बाई PR, PR is the rating 100 megawatt, PR value of PR is 100 megawatt। if you divide PG by 100 it will be PG per unit में आ जाएगा। demand divided by 100 it will be demand per unit। PR if you divide it here, this PR will be cancelled, B divided by 100 megawatt it will be B per unit। in this way this equation, because we know in the power system all the equations are written in the per unit form, so this equation is the equation which describes the model of the synchronous generator। now here again you see it is a differentiation term, just to solve it a differentiation term we have to take the Laplace of this। if you take the Laplace of del PG S del PD S, okay, then B plus 2H by F d by dt, Laplace of this is the SFS, Fs taken out from both the side it will be Fs, and this equation will come PG minus PD 2H by F plus B on this side, okay। so this is the equation with Laplace equation which describes the change in frequency of system in terms of Laplace। del Fs means Laplace inverse of this will be Ft, frequency in time constant, time domain, it is the frequency in the Laplace domain, Laplace form। so now again writing this equation PG minus PD 1 by S into B, 1 by S plus B divided by B here, B taken out, if you take B out it will come at 2H by FV into S, this 2H by FV is written as a TPS। in this way we have written again 2H by BF is the TPS and 1 by V here, 1 by V is the KPS. KPS is the, ये जैसे हमारे टरबाइन में था ना KT 1 प्लस ST, इसी तरह का ये बन गया KPS is the gain, TPS is the time constant of the जनरेटर। मतलब क्या हुआ, जनरेटर में जब सिग्नल आएगा उसके इतना टाइम लेगा सिग्नल को ये मैकेनिकल पावर को इलेक्ट्रिकल पावर में कन्वर्ट करने के लिए टाइम कांस्टेंट लिया TPS, PG minus PD is the net change in this. So it means this is a again model. This equation, this equation can be represented into the control system block diagram representation like this: PG minus PD. This is the PG minus PD, KPS 1 plus STPS and del FS. Okay, this is the block diagram model. So this model of the generator, then this model of the speed governor, and this model of the turbine. Combining all those model into one, we will get this complete block diagram. We will get this the complete block diagram model of load frequency control of an isolated power system. देखिए ये यही था KHG 1 plus STHG del PC minus del FS 1 by R, ये हमारा स्पीड गवर्नर का मॉडल था। यहाँ तक आप if you remember from here up to here and here, this was the block diagram model of primary automatic load frequency control. This was the block diagram of the turbine, which was converting this fuel opening into the output power, PT or PG, generated power or turbine power. This PT minus PG, recently we have described the generator model. This PG minus del PD demand is causing the change in frequency here. KPS, this is the generator model. So this is one complete model of the complete block diagram model of the system, that is the isolated power system. So is there any question up to now? यहाँ तक अगर किसी को कोई प्रॉब्लम है, you can ask. ये this is very important model. अगर आपको ये समझ में नहीं आया है, then you will not understand anything into the power system dynamics. इसको समझना बहुत जरूरी है। जब तक आपको ये नहीं समझ में आएगा, because we have described in very much detail, इसको बहुत ज्यादा डिटेल में हमने आपको डिस्क्राइब किया है, इसको समझना, because this is the foundation of the dynamics of the power system. तो इसको समझना बहुत जरूरी है। अभी भी अगर किसी को कोई क्वेश्चन है, इसको समझने में कोई प्रॉब्लम है, कोई क्वेरी है, देन यू कैन आस्क। इसमें किसी को कुछ पूछना है तो आप पूछ सकते हैं। हरप्रीत,
Yes,
आर
sir.
यू अंडरस्टैंड? हाँ, हैव यू अंडरस्टूड दिस?
Yes, sir.
जगवीर, हाँ जगवीर समझ में आ गया?
यस सर।
कार्तिकेय,
यस सर।
आपको कैसे समझ में आ गया? आ ही नहीं सकता है। Until and unless you go through the previous lecture, you cannot understand this. कैसे समझ में आ गया आपको?
सर आज जितना पढ़ा है उतना थोड़ा बहुत तो गया ही है सर, बाकी अब जितनी
बैकग्राउंड
क्लासेस है
अगर
वो
नहीं है ना, आपको पता ही नहीं है ना उसका बैकग्राउंड कैसे कैसे उसका वर्किंग था।
सर, वो ऑनलाइन क्लासेस जो आपने अपलोड करी हैं वो देखूंगा सर। फिर
अब देखोगे ना, तो अगर पहले देखा होता तो ये पूरी तरह समझ में आ जाता आपको।
हाँ जी सर।
हाँ, सक्षम,
यस सर।
आया समझ में कुछ?
सर थोड़ा थोड़ा आया सर। अब आपकी प्रीवियस क्लासेस जो है सर उन्हें पढ़ूंगा सर, उनको देखूंगा
तो
सर।
नेक्स्ट टाइम से आप पहले पढ़ के आइए। अगर आप एब्सेंट थे, पहले पढ़ के आएंगे और फिर आप ये क्लास अटेंड करेंगे, तभी आपके लिए यूजफुल होगा। ओके
यस सर, नो प्रॉब्लम, श्योर।
कोई नया व्यक्ति ने ज्वाइन किया है अटेंडेंस के लिए? दीक्षा इज प्रेजेंट और नॉट? नो। पवन इज प्रेजेंट और नॉट? अंतराम? नो। अरुण सागवान? Why others are not showing so much interest in the class?
ऑनलाइन
Yes.
पेपर सर,
क्या?
ऑनलाइन पेपर है सर उनका।
अच्छा, 3 लोगों का है ना ऑनलाइन पेपर?
यस सर।
तो एब्सेंट तो ज्यादा हैं। तो I think you are not having any query. So now once you understand the detailed model which we have just derived, once you understand this model, then we can do all the performance analysis. Performance analysis means how it will behave. Once the model is developed, we can do how it will behave on steady state. Means what is the steady state analysis? Steady state analysis means when you do one change, what will be the changes in the whole system, or how different parameters, different state will change. This is the steady state analysis. Then we can understand the dynamic analysis. Dynamic analysis means during that time, steady state means finally what will happen. Dynamic analysis at every instant of time what is happening. Suppose power हमारा 100 से 100 मेगावाट हुआ and finally आपको पता लगा और 100 से 200 मेगावाट हुआ और आपको पता लगा आपका फ्रीक्वेंसी 50 से 47 रह गया, बट 50 से 47 होने में अगर आपके 20 सेकंड लग रहे हैं तो व्हाट इज हैपनिंग एट एवरी सेकंड, हर मोमेंट पे क्या हो रहा है, दैट इज द डायनेमिक एनालिसिस. So we will study the steady state analysis, we will do the performance for dynamic analysis, we will do transient analysis, and we will see the effect of various regulators, how to improve that. The study or performing any analysis is not sufficient, but our purpose should be to improve the performance. हमारे उसकी परफॉर्मेंस भी इंप्रूव करना है, दैट इज अवर पर्पज. ओके, so that thing will be described in the next class.